Hello everyone, my name is Xiaobo Xue. I'm assistant professor at Department of Environmental Health Sciences of SUNY-Albany. So my team's work is focusing on sustainability assessment of water, energy, food nexus. I'm really glad to be here to learn from all of you about different perspectives and aspects about green design. For my talk, I'm going to dive into the intersections between the water, energy, and the food systems. At the end, I'm also going to introduce you guys a set of quantitative tools which can illustrate and quantify the costs and benefits of different green designs. So potentially that could be used as the scientific basis to support our green design. All right, so our presenters, Gail, May, and also David, already talked about the challenges of the green design and also the opportunities as well. So before we talk about the alternative wastewater or water design, so we have to look at what our current system looks like. So we all drink water every day. We also flush our toilets every day as well. So where does this water from, right? And also how we are treating the water these days. So usually we extract our water from surface and groundwater sources. And after extracted, and the water is pumped through very long pipelines, sometimes could be 3,000 miles. And after this pumping process or transportation process, the water is treated at water treatment plant. So within the water treatment plant, water will go through the physical chemical processes, and the impurities would be cleaned up, and then water is transported to the household, used for shower, drinking, cleaning, and all different purposes. And then water is collected and then transported to the wastewater treatment plant. And after treated at the wastewater treatment plant, usually is disposed to the natural waterways. So what's wrong with this system? Over the last 100 years, actually, it has been quite successful to provide us safe, clean water and also wastewater services. But what's wrong, really? Why do we need to change it? So first of all, thinking about this system, the overall system is really energy intense. It consumes about 3 to 7% of our national energy. Do we really have energy in the future? I'm not sure. Do we have sufficient energy? And also thinking about the water quality problems. So most of our wastewater treatment processes are based on secondary treatment processes, which has quite limited capability of removing nutrient. But nutrient, when it's enriched in our water body, it can result in water quality degradation, particularly in algal bloom and also eutrophication. So it can hurt our economy if we lose our fishery and also recreational opportunities. So we need to have better or stringent water quality policy for our wastewater. Besides that, and think about how old is our water system. A lot of them built 100 years ago, or at least 70 years ago. They are very old. They are in desperate need of repairment or replacement. Do we have money to replace them? I'm not sure. It's a really tough question for lots of cities and lots of communities. In addition, when Gail talked about the stormwater management design, we have to think about climate change, right? So, but unfortunately, thinking about our current water system, it's really not climate resilient. So sewer overflow occurs in Troy and also in many urban neighborhoods as well. So we do need novel systems to retrofit our systems. What will this new system look like? Different designers, different engineers may give you different solutions. So within this talk, I like to talk about several popular options we have so far. Let's rethink about our wastewater. What's in wastewater? Water, right? So 95% of wastewater is water. So, and also what else in wastewater? As we said, right? So it could be the poop and the urine. What's within poop? Carbon. What is carbon? Carbon is a potential energy source. What's within urine? Nitrogen, phosphor, which can be potential fertilizer source. So we collaborated with the University of Toronto and also several universities in the US as well. So we looked at the nitrogen phosphor composition within our wastewater. So here are some alarming results, which can be very exciting as well. So looking here, so within the wastewater, actually at least 70% of nitrogen is embedded within urine. So if we could convert urine into alternative fertilizer, potentially it can solve our nutrient issues for agriculture. And also thinking about the broader picture of agriculture, phosphor is really a challenge for our agriculture society. So lots of scholars predict we'll run out of phosphor next 50 years. And where do we have phosphor these days? Morocco, Russia. Unfortunately, not in the US. So, but we do need phosphor to grow our plants, to sustain our food needs. So, one of the potential solutions is to convert some of the waste into alternative fertilizer source. Another fertilizer we often use is nitrogen phosphor. So, nowadays, the majority of nitrogen phosphor is manufactured through Haber-Bosch process. So the gentleman, Dr. Haber, actually discovered this Haber-Bosch process back in 1920s. So essentially, he discovered that under the high pressure, high temperature condition, we could combine nitrogen and also hydrogen gas and turn those two together into ammonia. Ammonia essentially is the raw material for the nitrogen fertilizer. After that, Dr. Bosch scaled up the process and also made it into industrial processes. So these two gentlemen together won Nobel Prize because discovery of Haber-Bosch process. So nowadays, almost 99% of nitrogen fertilizer is from Haber-Bosch process. This process is extremely energy intense. About 3%, at least 2% of this world energy is used solely for Haber-Bosch process. So we do need some alternative solutions. So we need alternative ways to make our water system more sustainable, and also hopefully use the water system to provide alternatives energy, water, and also nutrient sources. Fortunately, technologies are available to achieve these goals. So first of all, so we can actually convert the wastewater into clean water. Here are some popular solutions. So on the bottom here, so is there a traditional solution? Essentially, we could combine the filtration and UV disinfection process to turn the wastewater into clean water. So essentially, on the left side, so these filters will trap the dirt, and so when the water goes through here, so the clean water will pass through the filter, and then the microbial agent will be deactivated during the UV disinfection process. So throughout this whole process, we can turn wastewater into clean water. And also we could also have an even more advanced design. For instance, here on the right side, so we could use the hollow membrane design. So with a little bit of pressure, so we could even improve the treatment efficiency. Essentially, the water will be passed through the membrane, so only the clean water will pass through the membrane, and then the water will be transported through this hollow membrane, and then reach the final users. And also, there are even more household or community scale design. So this is a commercial product which is available in the US and also Australia as well. So this is a more portable or more smaller scale design of a membrane bioreactor. So all of this technology actually can help us to convert the dirty water into clean water for use. Going back to that fertilizer issue, so we could use low technology solution and also high technology solutions as well. So if we install the urine diverting toilets, essentially we could separate urine from the rest of the wastewater. So this is how the urine diverting toilet looks like. So essentially in the front bowl, so there are a few holes. So this urine will go through these holes and then collected through the plastic pipe underneath, and then the urine can be stored in the basement. So the left side, this gentleman in India is using his family's urine to fertilize his own lawn. Actually, this has been the practices for thousands of years, particularly in developing countries, China, India, and also Africa. And also, if we do have a large volume of urine, so we could also use the tractor to spread the urine to the larger scale of the lands as well. A lot of you are laughing about this solution. And also some of you may think, oh my gosh, it's really gross to touch my own urine and also use my own urine for the lawn. I totally agree with you guys. It is a social challenge. This urine solution is also utilized in developed countries as well. So here are some examples. For instance, in Sweden, Germany, and also even in Seattle in the US, they all installed urine diverting toilets. We could also actually use the technology to convert our urine into struvite as well. So for that case, we don't have to touch that yellow, nasty liquid anymore. And also another amazing thing about this technology is that, so it's convert the urine into crystal form struvite. Struvite is a very nice fertilizer. It supplies nutrient needs for the plant throughout its entire growth cycle. So what it means that you only need to apply it once, so it will be sufficient for the entire year, which is a very nice feature comparing with the traditional fertilizer. So this technology currently already commercialized. So we know that one of the biggest wastewater treatment plants in Chicago is converting their wastewater into urine. And also another company called Strata already is selling struvite online as well. So here on the right side, here is a farm in Vermont, actually is utilizing struvite to fertilize their grass and also flowers, not for crops at this point. Another nice feature about this is comparing with the urine, lots of people, when we are thinking about urine, lots of people are worried about the pharmaceutical residue within the urine. But the struvite has zero pharmaceutical residues because struvite is formed under a selective precipitation process. So pharmaceutical residues is already removed during that process. So it has much higher purity and also low residue. All right, so we could also convert the wastewater into energy as well. So here are some popular options as well. On the right side, here is the anaerobic digestion process. So essentially, we are converting the wastewater, especially the carbon in the wastewater, into methane. Methane is the primary content of natural gas. It's a heat source, energy source. On the left side, so we are converting wastewater into electricity. So essentially, when the microbes are digesting carbon, electrons are donated. So if we could set up this process in a nicer way, so we would be able to circulate and capture the electrons and turn that energy into electricity directly. So those are some popular options to convert the wastewater into energy. And also our previous presenters already talked about. So another novel design of the wastewater is really think about how nature is treating our water and wastewater as well. So we could potentially use our soil resources, plant resources to clean up the water and also recharge the water to the natural environment. So this not only provide ecological functions, it can also provide public health benefits as well. So numerous studies already showed that the green space can lower cardiovascular diseases and also respiratory diseases as well. In addition, it can provide recreational space. So thinking about the history and the future of our water system, I think the future of the water system is a resource recovery based. And also this solution needs to include the green infrastructure as well. So our past, we have been using the big pipe approach, an energy-intense approach to treat our water. Recently, or 20 years ago, so we started to realize water is a scarce resource. So we started to improve the efficiency of using water. But nowadays, we really need to think water at a different level. We need to think about interactions between water, energy, and food. And also we need to think about water as a component of the ecosystem and also human society as well. All right, so as a researcher, so my team is developing a range of quantitative tools to assess the environmental human health impacts of the water systems. So we have life cycle assessment to look at the environmental impacts, and also risk assessment, particularly look at the chemical pathogen-based health risk associated with water. So we also look at the cost associated with different designs as well. In addition, we also have a lab to really test the treatment efficiency of the different solutions. Thank you so much, everyone.